Time for video notes 5.2. So we're going to talk about metallic bonding and acid nomenclature. Here's all the things I hope you can do when we're done learning this. Please read section 5.6 and also read pages 441 to 442 in your textbook. Okay, so let's talk about acids. Acids all have one thing in common, and that is hydrogen. So we haven't talked much about hydrogen making ionic bonds because usually it shares electrons. But when it does make ionic bonds in acids, it is an H+, okay? So usually the acidic hydrogen is placed in front of the chemical formula. So I'm going to play a little song here because we're sponsored by the letter H for hydrogen. And what do all of these compounds start with? We'll say it all together. Hello, 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 I'm hydrogen. And I'm at the beginning of an acid. Hello, I'm an acid. I start with hydrogen. Okay. So hello, hello, I'm an acid. Hello, I'm hydrogen. Hello, I'm an acid. I start with hydrogen. So here are some chemical formulas for acids. And how do you know? Well, hello, hello, hello. I start with hydrogen. Now, water is not an acid, but the rest of these are going to be called acids. So how do we name them? Well, here's the rules. All of the acids are going to start with hydrogen. So we have to name them based on the second part of the acid, which is called the anion, the negative part, anion. So if the anion originally ends in these endings, there are rules. So this is HCl. We know, hello, it's an acid, starts with H. So here's the Cl part of it. That's called chloride. So you have to change the name to hydroic acid. For example, since this is chloride, you drop the ide and add hydroic, hydrochloric acid. H2S, sulfide, drop the ide and add hydroic, hydroic. So we get hydrosulfuric acid, okay? What if the original anion ended in the letters ITE? Well, here's sulfite and nitrite. Sulfite and nitrite. How do we know they're acids? Because they start with hydrogen. Hello, hello. And so then you drop the ite and you add us acid. Ite, us acid. So sulfurous acid and nitrous acid. So this is H2SO3 and HNO2. All right. Well, if the original ion ended in 8, you drop the 8 and you just add ic acid, no prefix on this one, okay? So phosphate becomes phosphoric acid. Now you had to put the little or in to make it sound good. Phosphoric acid. And then chlorate becomes chloric acid. No hydro on these because they are 8, all right? So I have a little song for this, and it goes like this. How to name acids. I ate it, it was icky, and then I got the itis. I'd use hydroic. Yeah, I'd use hydroic. Don't worry, I'll sing it again in class. All right, so here we have some formulas. So let's name them. How do I know these are acids? Hello, hello, hello. Hydrogen, acids start with hydrogen. S is from sulfide. So I'd use hydrosulfuric acid. Okay. Hello, I'm an acid. I start with hydrogen. It comes from sulfate. So I ate it. It was icky. Sulfuric acid. I ate turns to icky. All right. Sulfites. SO3, -2. And then I got the itis. So sulfite turns into sulfurous acid. Okay. Next slide. Name and change it. Now we know we have acids. Look, it says acid in the name. We got to write the chemical formula. And since they're all acids, they start with H. H has a +1 charge. +1 when it's in an acid formula. So this is hydroic. I'd use hydroic. So it must have come from nitride. Nitride. Nitride is N-3. So then we still got to cancel charge. So it's HN3 is hydronitric acid. Ic acid came from 8. So nitrate is the second part of this. +1, -1, HNO2. And finally us, Come on, Harbin. 8, nitrate. Nitric acid came from 8. Us acid came from 8. Nitrous acid came from nitrite, HNO2. Okay, got it good. All right, so the last thing we need to talk about are metals. And we saw this in the metal non-metal lab. Though, so metals have variable bond strengths. Some of them can melt in your hand. So they have variable melting and boiling points. But what they are for sure is good conductors of heat and electricity. And they are pretty malleable and they're shiny. Okay, so what holds them together? Well, here's our model for metallic bonding. Okay, so this is aluminum. You can see aluminum there with its core electrons. What aluminum does is all the atoms in aluminum lose their outer electrons, but they don't lose them to a non-metal. They kind of lose them and then they can share all around everywhere. Okay, so they don't form compounds when they bond. It's just aluminums bonded to other aluminums. They're just bonded to themselves. Okay, and we call this, all those electrons that can move around and be shared, we call them non-directional covalent bonding. They're not stuck between two atoms sharing. That's covalent. All right. There's all of these valence electrons are allowed to move throughout the metal. Okay, so can we explain its properties based on this? We sure can. So here's a model. A shows the non-directional covalent sea of electrons for all of these gold cations. All right. So how does that show the properties? Well, this one, if you use this model, the electric current flows. You get your negative, and then the electricity flows to positive. What carries the current? Non-directional sea of electrons carries current. So that's why they conduct electricity. You put heat, the non-directional sea of electrons can pass the heat using those electrons. Okay, malleability. You hit it with a hammer, this non-directional sea of electrons that's being shared between all of them allows the metal to adjust and just change shape without cracking. Well, of course, you can't crack it, right? So bring down the hammer and you get a metal is malleable. Okay, so to review, hello, I'm an acid, so use the rules to name in my formulas. Metallic bonding model explains the property of metal by the sea of electrons. Make sure you've done that, and there's more. Okay, so far in this unit we talked about ionic bonding and all these properties. We talked about metallic bonding just now. And because we did the test before, you should be able to know these, because at the end of this unit, after the test, we're going to do a lab where you have to identify what's holding stuff together. Okay, so make sure you know all these properties. All right, so ionic bonding, brittle solid crystals, positive and negatives, don't conduct as solids, dissolve in water, conduct when dissolved. Wow. What happens to electrons? This is what happens in ionic, metallic bonding is a sea of electrons. And then here's all the bonding we've studied so far. I know this was the last unit. This was unit 4, but you still got to know it now so that we can compare all 3 kinds. All right, so don't forget this part, that even though we're not directly talking about covalent bonding in this unit, you still have to know that it was 2 nonmetals sharing electrons, don't conduct electricity, because all the electrons in covalent bonds are stuck in place. Okay, you could have polar and nonpolar covalent bonds, and you could have polar and nonpolar covalent molecules. I'm going to put molecules there. All right. Finally, here are some pictures of bonding models. Okay, this is a model because it describes what we think ionic compounds might look like. Another model and an ionic substance. Okay, metallic bonding. Here's a model for it. You got all your cations lined up, and all the valence electrons of those metal ions can move through the metal structure. Okay, another model. And there's some real stuff. Yeah. All right, and then covalent bonding. Here's some real stuff. Here's a model of the sharing electrons and the positive and negative side of the molecule, positive and negative side of the bonds. Okay, another model for carbon dioxide, sharing, and then a model for sulfur hexafluoride. Hey, let's practice. What type of bond is made of 2 metals? Okay, 2 metals is metallic. Okay, conducts as solid, metallic again. That's the only one that conducts when it's solid, because that sea of electrons can carry electricity. Has low melting point, usually covalent. can have low melting point, and that's the only one with low. But there are some metals that melt in your hand. Okay, it has electronegativity difference 2.2, ionic. Electronegativity difference of 0.2, covalent. What kind of covalent? Non-polar covalent sharing. Okay, and transfer electrons, ionic. Share electrons evenly, covalent if they're stuck in place. Okay, covalent, directional, stuck, stuck between atoms. I'm sorry, over here. Yeah, another example of nonpolar covalent. Has the highest boiling points, usually ionic, but it varies. Soluble in water, okay. That is ionic and some covalent, but the high electronegativity difference narrows it down to ionic. Soluble in water and low electronegativity difference would be covalent. Okay. And finally, mobile electrons shared by all cations. So there's no anions involved, so it's metallic. All right, I'm done with this, and I think that was quick. Please make sure you can do all of these things just to review. Metals have valence electrons, kind of a C that describes its properties. Covalent, sharing electrons evenly and unevenly. Ionic bonds transfer electrons. And how can you predict which type of bond is present? Well, you need to know the properties, the electronegativity difference, and the types of atoms. Make sure you have evidence to back up your bonding. Woohoo! And now it's time for me to say goodbye. I think this was less than 12 minutes. Peace out.